Hi again. In this video, I'm going to show you a different kind of correlation analysis. It's called chi-square analysis. Don't ask me where the word chi-square comes from. I don't know. It was just given to everybody. But chi-square is primarily used to look at the relationship between two or more nominal or categorical variables. For example, you are looking at the relationship between gender, male, female, gender, male, female versus smoking status, whether they smoke or not smoke. So these are both categorical. Or you're looking at gender versus marital status, married or not married. Or it could also be anything that is in which both variables are nominal or categorical value. So I've opened up my file here just to show you how to do chi-square analysis. Go to Analyze, Descriptives, go to Crosstabs. So Crosstabs is, I haven't found a particular button that called chi-square, but you can do it through Crosstabs to do chi-square analysis. For example, I want to see whether gender has anything to do with ownership of digital tools, whether male or female are more likely to own or not own digital tools, right? So then I can go to the statistics chi-square. I can also click on other like pi and Kramers or even correlations. Continue, observe and expected. Typically you need to have both, observe and expected. And that's pretty much it. I am not worried about the others. I'm just going to go to paste. Right, so the crosstab here is the main function of the analysis. I'm going to arrange them and run. See? So this shows what the gender here, this table. Gender, male, female, and the relationship with ownership of computer tools. These are the actual count, 5, 6, 5, 6, and these are the expected count. Right? So look at directly into the chi-square test. This is the most important table. It shows that the relationship between gender and whether the gender has anything to do with whether they own or not own digital tools is 0.697 for two tail or 0.4. Both of them are actually bigger than our threshold p-value of 0.05. So you can see this significant value is not significant, right? It's not significant. So you can say, or you can conclude that the gender is not related, is not associated with ownership of digital tools. So that's a simple conclusion that we can draw. What if we say the relationship between gender and alcohol drinking status? We can do the same. Go to Analyze, Descriptive, Crosstabs. So same gender on whether they drink or not, drink alcohol regularly or not. Right? Statistic is the same. This is the same. Go to Paste. This one, range it. And we're looking at the gender and whether they drink or not drink alcohol regularly. So the chi-square test also shows not both of them one-sided or two-sided tail. We can use this one as a more conservative one. It shows that the p-value, the signal value of this chi-square test is not significant because it's bigger than 0.05. We want 0.05 or lower. The lower the better, the significant value. The lower the significant value means the more confident we are that the result is not by random chance, but it's because that is the real truth. Right? So the Fisher exact test shows it's not significant. So we can conclude that the gender has nothing to do whether people own or not own digital tools. You can also do another one. Descriptive, crosstabs. Now we are looking at whether ownership of digital tools have any relationship with whether they drink or not drink, right? Same thing. We just click paste and run that one. Is there any relationship? Of course, no. So whether you own or not own computer has nothing to do with has no relationship whether you drink or not drink. So the p-value is also bigger than 0.05, which means that this is not significant. It means that there is no relationship between these two nominal or categorical variables. Ownership of digital tools and drinking or not drinking has no relationship. That's it. Thank you.